Our next pair of special angles are adjacent angles. Adjacent angles are two angles which share a vertex and a side, but have no common interior points. We'll look at a couple examples here. Angle ABC. So recall, angle ABC has sides BA and BC and vertex B, which means an adjacent angle needs to share the vertex and one of the sides. So we will now create angle ABD. And actually, even though angle ABD and ABC both share side AB and vertex B, they are not adjacent angles. The reason is because if we were to shade in angle ABD, and if we were to shade in angle ABC, we see this overlapping space. And that is where they have common interior points. So clearly that didn't work. Let's start over. We'll start with angle ABC again. But this time, we'll look at angle CBD. Okay, so CBD shares the side BC and vertex B. But if we shade in the angles, we notice that there are no common interior points, which works. So we find that angle ABC and angle CBD are adjacent angles. One thing to make note of here is that complementary angles and supplementary angles can be adjacent or non-adjacent angles. So what we should notice is that I can have two complementary angles that are adjacent. They share a side, they share a vertex. In which case, ADC needs to be a right angle, because ADB and BDC are complementary. So here we have ADB complementary to angle BDC, and angle ADB and angle BDC are adjacent. We can also have two non-adjacent angles, like the two ones in green that I just sketched out, in which case they are still complementary, but they do not share a side and a vertex. They do not meet the definition of adjacent angles. You can see the same thing with supplementary angles, which I'll leave you to do on your own. If you have any questions, as always, feel free to ask.